Good day and welcome to our today's class. Today we are going to be looking at question number 15 under simple stresses and strain. Now the question says a steel wire 1 millimeter diameter is stretched horizontally between two fixed points. This is the fixed point 1, this is the fixed point 2. Of course, they are stretched 2 meters apart. You can see in between the two fixed points you have 2 meters. Now a vertical load is applied at the midspan, which is P here. It causes a vertical displacement of 45 millimeter. So from here to here is nothing but 45 millimeter. Of the point of application of the load applied, what will be the stress induced in the wire and the load applied? We are told to neglect the weight of the wire and take E, which is the modulus of elasticity of this material, which is steel, equals to 200 giganewton per meter squared. So now our data, I'm going to be bringing out our data. So data given. First, we are given what? 1 millimeter diameter. So our diameter D is equals to 1 millimeter. So secondly, we are given our our length of the span to be 2 meters. So length is equals to 2 meters. Next, we are given what? We are given our displacement. Our displacement D equal to what? Is equals to 45 millimeter. Of course, we can choose to express our unit in meter. We divide both sides by 1000. We're going to be having what? We're going to be having 0.045 meter. Similarly, here, if we divide by 1000, equals to 0.001. Next, what do we have? We have our modulus of elasticity as 200. We have E equal to 200 times 10 to the power of 9 Newton per meter square. Of course, you know that giga is nothing but 10 to the power of 9. So next, what are we going to do? I'm going to be drawing a diagram here from this one. I'll be drawing a line representing my load here. So this line is representing load P. Of course, I can call here to be A and here to be B. I will have my center line. Next, I'm going to be drawing from A line parallel to LN. So from A, I'm going to be having a line parallel to LN. From B also, I'm going to be drawing a line parallel to MN. Parallel to MN. I can call the point where they meet to be C. Now, don't forget that as a load is applied on this wire, tension is being produced. So, of course, you can see the tension from the diagram in the question. I have T here and I also have T here. Now, of course, this makes an angle here. You can decide to name that angle phi. So this diagram, of course, I just produce it from this. So next, I'm going to be taking the sine of that angle. Of course, from our SOHCAHTOA, we know that sine is nothing but opposite all over hypotenuse. So this will be equal to, of course, the opposite of this angle is this, but the total length is P. Of course, we know that here will be nothing but P all over 2. It's half of P, and here will also be P all over 2. So the opposite will be P all over 2. All over, we said hypotenuse, which is what? Which is T. So this is what we have. I want to make T the subject of my formula. If I do that, T, I'm going to have T sine alpha to equals to P all over 2. I'll divide both sides by sine alpha. Where sine alpha goes with sine alpha, it implies that T will be equal to P all over. If you take the inverse of this, of course, you know this will be nothing but 2 sine alpha. So this is what we have. Now, look up. What we are going to do next is this. You see, for a very small angle, for a very small angle, sine alpha, for a very small angle, For a very small angle, sine alpha can be equal to what? Can be said to be equal to tan alpha. How do we verify this? We take the alpha, take the sine of a very small angle and take the tan of a very small angle. You will discover that they will be equal. For instance, if you take the sine of 0.045, you will discover that it will be equal to the tan of 0.045. That is where we assume that 0.045 is our angle. Take the sine and take the sine and take the tan, you realize that they will be the same. So in place of sine alpha, we can substitute tan alpha. So we are going to do that here. It implies that we are going to having t to be equal to p all over 2 sine. Now it will be tan alpha. So this is what we have. Now, from this angle here, I am going to be taking the tan of this angle. Now, from here, tan, of course, is nothing but opposite all over adjacent. So the opposite of this angle, of course, is the displacement, and the adjacent, of course, what is adjacent here is 1 meter. So this implies that it will be equal to p all over 2 tan alpha, which is what? D all over what? All over 1 meter. So next, what do we have? Of course, from our question, we have our displacement, which is D, to be equals to what? 45 millimeter. We have converted that earlier to meter, and it was equal to 0.045. So what we have here will be T, which will be equals to P all over, what we have here is 2. We're going to do 2, yes, multiply by 0.045 all over what? All over 1 is what we have. So if we solve this, T will be equal to what? 11.11 P. So just do the math, and T will be equal to nothing but what? 11.11 P. So this is our value. So next, we are going to be looking for our displacement. So next, I'm going to be looking for my displacement, that is my change in length, just like I said. So the change in length of this wire will be nothing but what? Now, we have a wire here and we have a force acting downwards. Of course, we know that this wire has elongated. Now, in order to get the elongation produced, because of course we know that the length from here to here will be more than the length from here to here. So that addition is of course the change in length. So in order to get the change in length here, we are going to be using what? Pythagoras theorem. Now of course Pythagoras theorem says the square of the hypotenuse is equal to the sum of the square of the two other sides, which is the opposite and the adjacent. So of course the L, which will be representing our hypotenuse side, will be equal to what? The square of what? What we have here is the displacement, which is the square, plus what we have here next is what? We are having 1 meter here. So we have 1 meter squared, all squared. So this is what we have. So next, what are we going to be doing? Of course, we know that our displacement is nothing but 0.045. So it implies that we have the L equal to 0.045 all squared plus 1 squared all squared. So this is what we have. So we are going to be, now when we get the value of this, the value of this will be nothing but the length from here to here. So next we are going to be subtracting 1 millimeter, 1 meter rather, from the value we get from here. That is the length we get, which is our change in length. We are going to be subtracting 1 from it to get that elongation after the load is being applied. So next, we are going to be having this thing, it will be nothing but the L to be equal to the square root of 0.045 squared plus 1 squared minus what? Minus 1. So this is what we are having. So if you do this correctly, you'll be having your DL to be nothing but 0.045 0.001. Of course, it will be in meters. So this is our our change in length. So of course, the change in length due to this force P added is nothing but what? 0.001 meters. So next, what do we do? We are going to be looking for strain, which is E. We are going to be looking for strain, which is E. We have 0.01. We know that strain, of course, is our change in length all over our original length. We are having 0.01 as our change in length, 0.001 as our change in length all over our original length, of course, is nothing but 2 meters. So we have all over what? All over 2. This is our original length. Now 0.01, of course, divide by 2 will give us what? You have to note something from here. We are having this to be our change in length. Of course, we are considering just this section. So we are not going to be using the length of the entire span. So here will not be 2, here will be 1. Do not make that mistake. We are considering this span, not the whole span. So 0.01 of 0.001 all over 1 will be equal to 0.001. Course, strain is limitless. So this is our value for strain. So next, we are going to be looking for stress. Sigma will be equal to what? Of course, we know that sigma is equal to what? Force all over area. Sigma is equal to force all over area. So now, what do we do? Our force now, if you come back to this question, they said what will be the stress induced in the wire and the load applied. Now the stress induced in this wire, of course, is the tension T. So our tension T now will represent the pull, that is the magnitude of this wire. So now we are going to have T, and of course T is what? 1.11 P. It will be all over our area, which will be pi by 4. Pi by 4 into what? D square. Of course, our D is nothing but what? 1 millimeter, which we have converted to be 0.001 meters or square. So if we solve this, what will be our sigma? Of course, sigma will be nothing but 199.9 times 10 to the power of 6 Newton per meter square. So we have 199.9 times 10 to the power. So when you solve this, you're not going to have this value. Please ensure you press your calculator correctly. When you multiply here, you are going to take the square of this, multiply it by pi and divide by 4. Then divide it by 11.11. So if you do this, you're going to be having 14.14 times 10 to the power of 6 P Newton per. You're going to have 14.14 times 10 to the power of 6. P will remain. Of course, we don't know the value of our P yet. Newton per meter square. So make no mistake, ensure you press your calculator correctly. So next, that's what we have for our stress for now. I'm going to be wiping this slide as we solve further. So we have a value for stress and we also have a value for strain. We can use our modulus of elasticity formula, which is equal to stress all over what? All over strain. So this is what we have. So if we substitute our values, of course, we know the value for our modulus of elasticity is 200 times 10 to the power of 9. So we have 200 times 10 to the power of 9 to be equal to stress. What is our value for stress? We have 14.14 times 10 to the power of 6. All over our value for strain is nothing but, don't forget our P, we are having P here. So our value for strain, of course, is 0.001. So this is what we have. Next, we are going to be cross multiplying. Of course, if we do that, we're going to be having 0.001 multiplying this, which is 200 times 10 to the power of 9. It will be equal to 14.14 times 10 to the power of 6e. Now, this is what we have. Next, we are going to be dividing both sides by the coefficient of P, which is 14.14 times 10 to the power of 6. 14.14 times 10 to the power of 6. Of course, 14.14 times 10 to the power of 6, you go with 14.14 times 10 to the power of 6. P will be equal to what we have here. So I'm going to be wiping this side as we will be dividing this to get our value of P. Of course, if we divide what we have here by this, P will be equal to 14.14 Newton. To press your calculator correctly, divide what we have here by divide the denominator, divide the numerator rather by the denominator, you have 14.14 P. Now, do not forget that sigma is equal to what 14.14 times 10 to the power of 6 P. It implies that we can substitute our value for P here to get sigma. Of course, this is our first value from the question. We are asked to find the load applied. This is our load applied P. Next, of course, we just need our stress, and we have gotten sigma, our stress, to be equal to 14.14 times 10 to the power of 6P. Now we can substitute the value of P, which is 14.14 Newton. It will be equal to 14.14 times 10 to the power of 6. What we have here is multiplying 14.14. Of course, if we do this, it will be nothing but 199.9. You make 199.9 times 10 to the power of 6 Newton per meter square. Of course, we know that 10 to the power of 6 is nothing but mega. So this will be equal to 199.9 times 199.9, 10 to the power of 6 representing mega, have our Newton per meter square. So this is the stress induced in the wire, and this is the load applied. So I hope you understand this video fully. If you have any comments, have any question, have any contribution, you can leave it in our description box. Be sure to like and subscribe to our YouTube channel. Of course, the link to our WhatsApp group is in the description box below. You can click to join, and you will get lots of inspiring content, and you will enjoy it. Thank you for watching.